Good morning, chemists. So we're going to take a look at a very common problem in a chemistry class, and that is this problem. It says if I have 3 moles of hydrogen gas, how many moles of oxygen gas will I need in this reaction? And so we already talked about making s'mores, right? And if you're given a recipe for s'mores, it's easy to understand how to go from, say, if I have 10 graham crackers, how many marshmallows do I need? This is the same question, same exact question, and this is our recipe. So a couple steps are needed when solving a problem like this. The first thing we have to do is we have to balance the reaction. Okay? So what I'm going to do is I'm going to come here and I'm going to balance this. Now there are a couple ways you can balance. If you feel that you're pretty good now at getting the coefficients just using the numbers, you can do that. I'm going to draw pictures to help. So H2, I'm going to draw 2 atoms of H. I'll make those red. And then I'm going to draw 2 atoms of oxygen. I'll make that purple, right? And the reason there's 2 is because it's H2. The reason they're connected is because it's a subscript. If it was in front, they would be separated, right? And then H2O over here is going to be 2 red and 1 purple, right? So to balance this, we see that on the reactant side here, we have 2 atoms of oxygen. On the product side over here, we only have 1 atom of oxygen. So I'm going to need another H2O, like that. And now that gives me 2 oxygens, which now is balanced. But on this side, I see that I'm going to need another H2, right? So my final balanced reaction is going to be 2, 1, and then 2 of these. So now that we have our recipe, we can answer this question. If I had 3 moles of H2, how many moles of O2 will I need? So the way we're going to set this up is we're going to take our starting ingredient, right, which is H2, and we're going to say, so what I'm going to do is I'm going to take this 3 moles of H2, and what we're going to need is we're going to need a conversion factor here. And the conversion factor is what we call the mole ratio. So we're going to find the mole ratio. Now, what are the 2 things we're going to find the ratio between? Well, it's H2 and O2. Just like in the s'mores example, if I have 10 graham crackers, how many marshmallows? Graham crackers and marshmallows would be what I would look at. Here, it's H2 and O2. And what I see from the balanced reaction is that the mole ratio is 2 to 1. So the way I can write this mole ratio is like this: 2 moles of H2 over 1 mole of O2. And now how I write this, I can flip it. I can write it this way, or I could write it this way. The way I'm going to write it here is the way that I want H2 to be crossed off. So I'm going to put H2 on the bottom. So I'm going to use this version of the mole ratio. Right? So then moles of H2 goes away. I can cross multiply 3 times 1 divided by 2, which is 3 times 1 over 2. And then the unit that's left is moles of oxygen. So 3 over 2 is 1.5. Right? And this answer should make sense to you. I need twice as much hydrogen as oxygen. So if I have 3 hydrogens, I need 1.5 oxygens because that's half as much. And so that's how you do a simple mole-to-mole ratio stoichiometry problem. Good job, chemists.